Thank you for joining us. I will be taking you through a little bit about the Power Up. Is the Power Up production smarter, leaner, and tariff-proof? This is more geared towards the manufacturing of the factory floor, effectively. My name is Ajay, and I will be taking you through all of these information as we go along. So, on today's agenda, we will quickly run through an introduction. We'll discuss today's challenges and the challenges that are being faced by the manufacturing industry or the machining and manufacturing industry as a whole. Then we'll talk a little bit about the process digitization, which is as part of the solution to the challenges, to some of the challenges that we will be discussing. Then we will talk a little bit about the key features of the product that we are talking about, which is Autodesk Fusion Operations. I will run you through a couple of quick demonstrations with regards to how it works and what sort of problems that the software will potentially solve. And then we'll quickly have a quick summary as to what happened, what we discussed today. So first of all, who are we? We are Baker Baynes. We are a digital transformation company that assists customers digitize their processes from an engineering, from a manufacturing, from an architectural and process flow perspective. We predominantly find ourselves doing three major core features. One of them is consulting, then we do education and hardware and software. So we will find ourselves mostly in these process plant manufacturing, energy, civil and building industries. We do have a tailored customer-centric approach. We are a BBBEE level 1 contributor, and we will assist our customers and yourselves guide through the digital journey. One of the things that we do is solution sales. So we sell solutions from the Autodesk perspective from other software partners that we have, such as ClearEdge, CoolOrange, and Leica. In addition, we also do provide education and training. So we are a training center as well. We are a Autodesk certified training center for Autodesk, as well as we do partner up with a online e-learning portal called Pinnacle Series that is presented by Eagle Point. We actually use our technology and our knowledge base to assist customers to digitize processes, to digitize manufacturing, to digitize engineering and design. So for today's topic, we will be talking about the manufacturing aspect of it. So today's speaker will be myself. My name is Ajay. I do hold a mechanical engineering degree with a lot of experience in the design and manufacturing industries. I have worked as a project engineer and a project installations manager in the construction industry, as well as have a postgraduate diploma in engineering, but more focused on lean manufacturing quality management. Enough about me, though. Let's quickly jump into the current challenges that we face today in the manufacturing industry, especially in South Africa. We will also be talking a little bit about how we will be reducing costs in order to tariff-proof our processes. So factories have come a long way in the past sort of century, few decades, where a lot of the process of production mechanisms have been automated, improved over the years. There's with the advent of the assembly line and through the 4 different industrial revolutions that we've been through, we've got improvement in quality of manufacturing, we've got improvement in manufacturing processes, but at the same time, we also have more further to go, because even today, there are a large number of manual and disconnected processes that are part and parcel of the way we work as a group, right, in South Africa and the rest of the world. Now, some of the big challenges that we have, there is a lot of waste that occurs as a result of rework because the process hasn't been fully properly defined. In this case, any missed outputs lead to massive cost outlay. A missed deadline in this case is not just a delay to market, but at the same time, you're talking about capital equipment which you have paid for, which are standing idle, and that money needs to be made back somehow. In this case, exceeding budget obviously decreases your return on investments and so on and so forth. But for the most part, we will be talking about that 70% that you see here on screen, where it's dependent on spreadsheets and manual entries. So if we're talking about spreadsheets and manual entries, we're talking about how we deal with everything. All the production planning is done on a spreadsheet or a whiteboard. We have your toolbox talks and so on that go on in the mornings or once a week or whatever the case may be. But there are a few issues that will come up with that. Most importantly, we have a real lack of real-time visibility in the process. So when we're actually busy with the process, we don't really see what's happening in the process necessarily immediately so that we are able to react. So we'll talk about that as we go along as well. So what do we define as success in productivity? We're talking about high productivity, profitability, meeting and exceeding the customer's expectations, gains in efficiency from our perspective as well as the manufacturer and as the designer for the product. But we do have a lot of obstacles that come in the way. So supply chain delays can happen. So with South Africa, we also have this issue with the shipping, the port issue that we have, the delays at port and so on and so forth, but also at the same time, sometimes the suppliers actually start falling out of business. And this is another direction where we can assist to improve the supply chain delays and to mitigate for such delays. We're talking about the availability of the workforce. So we do have a skills drain that's happening in this country at the stage as it stands. And that skill shortage does lead to a lot of companies having to find people and potentially employ people that may not necessarily have that the skill set, and in terms of all of that, the fact that the people who have the skills are not always available to do what needs to be done. The production workload, if we want to increase profit, we need to increase production. Simple as that. So that increase needs to be managed. It needs to be defined. It needs to be made more efficient. And currently, we also have a lot more shortened lead times as it stands because we're looking to manufacture faster so that we can increase the throughput, so that we can actually increase the production, and so on and so forth. So it becomes a cascading effect. Now, what is the most important aspect that allows us to improve that, to move away from the obstacles and achieve the measure of success that we would like to achieve? The answer to that question is data. Data is transferred back and forth between your design team, your sales team, your production team, and all of that data, if used correctly, can assist the customer, yourselves, to do a lot better, make yourselves more efficient, and in the longer term, for the bottom line, to improve our profitability. So the typical production process, production workflow goes like this. We have a production or work order, then we have to check for materials. If we've got the materials, then each operation exists one after the next, and so on and so forth. So the first question we need is, how is the process started? Are we talking about a sales document that comes through to the design team? Is there a PDF document that's generated and approved? Is there a purchase order that goes through to the department that needs to do the design and manufacturing? And so on. Those sort of questions also need to be addressed. Then the next one is, how is the production information moved? So from one phase to the next phase to the next phase, what defines what the next task is? What defines what needs to happen in terms of a sequence of events that need to occur until such a time as the product becomes a saleable item? And finally, but very important still, is how is the production tracked? What is defining where each component is in its operation? What operation is it in at the moment? If there's a delay, why, and so on. All right. So in order to do that, so the production tracking aspect of it will start with the common methods that are being used currently. Is we've got the paper traveler, the spreadsheets, and the whiteboards. So we spoke about that a little bit earlier. So the paper traveler is a printed document which contains it's basically a job card that we use in the factory. It goes from one workstation to the next workstation along with the component that's being manufactured. The other mechanism is that the management team or the production line manager will then end up using a spreadsheet to track where each component is in the morning or in the afternoon. That'll be filled in individually. Well, this can also be done via a SharePoint document. And then there's the whiteboard. So every morning, 10 minutes, you say, okay, this is what we're doing. Each workstation needs to be doing X, Y, and Z each day, and we need this amount of output. This is a very manual way of working. Now, this paper traveler concept is working on a template form with a initial digital entry. Then it gets printed out and sent through the factory, as I said, as a job card, and distributed through to the workforce as needed. And when the specific task needs to be attended to, the worker will then receive the paper traveler. And all of this data is entered manually. So as the job comes in, it is filled out. And then as it's completed, it is then signed and sent off to the next stage. Now, in the production process, we're talking about the paper traveler, which goes all the way through the process from stage one all the way to the output. Everything is entered manually, and we will then check, if somebody from the upper floors need any information, you would need to go and track where the paper traveler is and then go and see what it looks like, and then interpret the data from there and react accordingly. Okay, so looking at the picture on the right-hand side, which is a fully filled out paper traveler, it doesn't look very pretty, does it? At the stage where at this point, where at the end of the project, the paper traveler looks a little bit worse for wear, all the writing in it, all the dirt that comes in from the factory, it gets squished, it gets crumpled. All of that can actually make it very difficult to read, and data can get lost along the way. And if there's additional information that needs to be inputted here, more beyond what the amount of space there is available for comments, it starts getting squeezed into that space, and then in the heat of production, obviously, there's also the rush that people will also have a tendency to not fill it out correctly or completely because they would just want to get on with the next thing. So at the end of production, this data comes back to management, and this delays the visibility of all the data that's happening, all the information that's being presented or created as the production process continues. And this data becomes difficult to analyze. It's a post-scripted data. Now, the people who are looking at this data are looking at outdated data. It's almost like saying that the light we see from the moon is 8 minutes old, or the light we see from the sun is days old, or whatever, 8 hours old, or whatever the case may be. So it's not immediate. So going back to this, even if we completely fill out the paper traveler exactly 100% as it should be accurately with all the data, all the information, it also still takes a while to get back to the team that's analyzing it, right? So initially, right, when we start a process, we need to check to see if we have materials in stock. So how does this work? We would basically pick up the phone or take a walk to the warehouse and say, okay, listen, do we have the materials, raw materials for product A? And that takes time. So there's walking time, there's calling time, then the person who's in the factory needs to check their systems and so on and so forth. And that actually then goes and becomes a bit of a time delay or a time buffer that we don't really want necessarily. So these are things that we can actually improve upon on the process of today. The operational availability is another issue. So if we are now sitting on a machine operator or a machine itself having been overutilized, in the sense that when you want to when you start creating bottlenecks, where you start assigning processes and procedures and production to the specific machine, you've got other locations where that request would come from, and that machine could potentially, or operator could potentially be overworked, or creating a bit of a stagnation point in your process. That's something that we need to also look at, because we need to check the operational availability of the machine as well. So that's another sort of thing that we can maybe just talk about as well going forward. The next thing we want to talk about is, now there's data that's coming through from here. How do we analyze it? Where do we analyze it? And when do we analyze it? The when becomes very important as well, because at the end of production, if we can then just go fill all of this stuff into a database or a worksheet, what exactly is it, the benefit from it? It's great for pushing it forward into the next time we actually do the same process. What can we do to improve the next thing? Right? What can we do? It's great. It's fantastic. But on the same token, can that also not be just improved slightly in terms of the timing of the data that we get back? So all of this leads to potential missed deadlines, bottlenecks that I was talking about in terms of machine overutilization, the processing costs that go up with material rework and waste, and if we don't have an inline quality process, or if, again, quality is not it's not an afterthought, because at the end of the process, if you go and realize that you've got 10 out of your 20 products is outside of spec, you're looking at a 50% material wastage. So, looking at things like that, the processing costs and your waste and scrap increase as well. Then we've also deal with traceability issues, because, again, traceability is not something that we need to look at and find after the fact. We're looking at traceability in the immediate. So we need to find that the traceability is We need to find out what's happening on each stage, at each process, at each machine, by each worker, what is happening, when is the stuff coming out, what's the speed of it. Takt times can be calculated, need to be calculated, and then also the raw material sourcing, as we discussed. So all of that creates a few issues or potentially locations or points where we can improve our production process. And what do we do to fix that? So the first thing we're going to talk about is the Autodesk platform. The Autodesk platform is a completely connected system where Autodesk, between the three platforms that you're seeing on screen, between your Fusion, Forma, and Flow, your Fusion is from your manufacturing perspective, your Forma is from your architecture, engineering, and construction side, and then you've got your Flow. So when you're designing a factory, for example, the ability to interconnect absolutely all of those processes where you want to know what you're making, how you're making it, what are the procedures to make it, what are the machines that you need to make the product, fitting into what building, where's the factory design, how is that being set up, how is that being built, how is that being refurbished. All of that processes get connected directly using the Autodesk platform. So the flow aspect of it is also the visualization. So we can also then create a visualization so that they all sort of work in a circle instead of in isolation with each other. Now the platform services then take all three of those platforms, put them together into one platform, and allow the person or the team who's creating either a new factory or redesigning a factory to be able to communicate between all three of those processes. Then, the aim here is to seamlessly connect the factory life cycle from start to finish for efficiency and effectivity of development and operation. And operation is where we're going to focus a little bit on from here. So process digitization will then be the next step. What do we do from here? Okay, so first we're going to talk a little bit about the different definitions of the concepts that happen in a what's just happened here? Just give me a second there. Okay, let's reshare that. So let's get back to it. Sorry, guys. That was a little bit of a technical glitch that happened. We will continue from here. So we're talking a little bit about the different definitions that form part of a production process and an entire organizational process as well. So we're talking about PDM, which is the product data management, which is a system that centralizes your product data. Product-related engineers use this to track revisions, manage change orders, and so on, generate bills of materials. All right, then we've got the PLM, which is product lifecycle management, which takes that step a little bit further, which stands for is a system that is used to manage the product development lifecycle from the point when you design the product to the point when it's sold and actually brought back and surveyed in order for us to be able to check to see where the or what the what it looks like in industry, right? So moving on. Then talk about the next stage, which is the MRP, which is material requirements planning, which is simply a resource planning tool that allows you to check to see what when you do your forward planning for your production, what resources do you have available, what do you have in stock, what don't you have in stock, and so on. Another very interesting thing about this is that it allows you to control your inventory, because inventory is money that's not being made. That's a concept that comes from lean manufacturing, where if you're sitting on a lot of product that's not being sold, you're not making anything out of it. So it's just money that's hanging there. As well as a large amount of raw materials. Again, it's money that's capital expenditure that's allowing a lot of materials to be in site. The storage space costs, the cost of the materials that you've bought, and all of that will then come into account there as well. Okay. The next stage we're talking about is the ERP, which is Enterprise Resource Planning, which then encompasses a larger amount of this, a larger portion of your organization from a customer relationship management perspective, human resources, and your supply chain management. It incorporates MRP into it as well. This is used in larger organizations where there is the time and the ability to actually implement such a large system, because it's an all-encompassing system for the majority of things. And the scalability of an ERP is also a little bit iffy when you talk about it. Then the last thing we're talking about is an MES, which is the manufacturing execution system, which is a system that monitors production, in short, relying on real-time data. It picks up what data you've got, what you need to actually produce, how fast, how soon what the deadlines are, when the production needs to be out, where the production is, and on top of all of that, do we have the material for the production? Okay. So continuing on the whole track, we have two streams. On the left-hand side, we're looking at the manufacturing, the design, the design side of things, where we're talking, data management, change management, design collaboration, bill of materials, and design review, and so on, right? And on the right-hand side, we're looking at more the product manufacturing side of things. So looking at production scheduling, manufacturing resource planning, manufacturing executions, purchasing and accounts, HR, and CRM. So all of that together, we're looking at the two software packages that we're looking at. We're looking at people who want to do all of these individual tools, not tools, but individual assignments and tasks that and we want to start automating that going forward. Now, there's a large number of tasks that have been brought up here. This is by no means an exhaustive list. There is a lot more that goes into any manufacturer and any company that does production. So anything, this kind of does give you a little bit of a sort of a cross-section of what the majority of production teams will be going through, the different types of tasks that they will be doing. Now, considering this, and if each one of these had to be a manual task, you just think about how much of a pain this would be, how difficult it would be to work with. So what we're looking for here is a software solution to automate all of these things, but at the same time, make it more efficient and assist with speeding up all of the production process, right? Because ultimately, if you don't have a product to push out, there is no income. Okay. Then taking it further, the left-hand side stuff of it will fall into the PLM side of things, which is your bill of materials, data management, design review, and so on. Whereas the product development aspect, where you're looking at now, again, if we're looking at design collaboration and design review, the design review is something that could happen post it going out onto the site or on to a customer, and then any reviews that come back will then also inform how the next one will be designed, or when whatever design improvements need to take place. And the ERP will contain all of the the production scheduling, linking it to sales, linking it to inventory, that sort of thing. And then it also takes us through to the purchasing and accounting side of the business. Because with the ERP, using purchasing and accounting, the accounting team will actually see what money is coming through. The purchasing team needs to know what inventory that they need to actually update and improve on, and increase in order to improve the production flow, the process flow of our production team. Production. Right. Now, taking it a little bit further, what we're talking about today is a manufacturing execution system, which is an overall that contains a quality management, manufacturing resource planning, production scheduling, and manufacturing execution. The actual production work, what happens on the floor, how does each operator do what they need to do? So let's take that a little bit further, and we will be talking about Autodesk Fusion Operations as the software solution, as an MES system. So talking about traditional MESs, these are simply tools that have been used in the past to digitize the paper traveler that we spoke about a little bit earlier. The paper traveler is that one that's manually filled in and every stage by stage it needs to be filled out, goes through the process and so on and so forth. What we're looking for is like something to actually automate or simplify that. Now, traditionally, the MES systems that have happened in the past are a little bit large and bulky. It takes between 6 to 18 months to execute, to put together, because it needs to incorporate all of the data that's currently in system. So if you're looking at a large archive of, let's say, thousands and thousands of PDFs that need to go into the system and need to be filled into the system so that they can be, the future can be tracked. So that takes a very large amount of time to put together. So what we're looking for is something that's fast, that's cheaper, and improves the user adoption. So the slow user adoption means it's the complexity of the system that causes user adoption to not work to the extent that we would like, because if it's a slow adoption, it means it takes longer for the process to be implemented. And if the process is implemented slowly, it takes even longer to actually show results. So what happens is that, and licensing costs also tend to be quite a limiting factor when it comes to this, because you've got licensing for the software, then you need the hardware that actually works with the software, and all of those sort of things that come into play. What we're looking for is something that's fast, affordable, and efficient. Right? We need to get to a point where we take a lot less time to start tracking our production. It needs to be cost effective and scalable from a small to a larger, to a medium and a larger organization, simply because it's not always feasible to go and pay a large portion of money, $250,000 rand, R500,000, for a ERP system that does way more than what you need it to. So the cost of the ERP systems is one of the limiting factors that we need to definitely have a look at. And then easy adoption is something that we also need to definitely have incorporated in order for the users to easily be able to move across without the need for excessive additional hardware, a complete change in the way they work. All it takes is basically one quick implementation, a little bit of training, and then we need to actually take that going forward. Okay. This is one of the reasons why Fusion Operations is a different piece of software. And let me quickly show you a short video just to show you an overview of what Fusion Operations is.
Operating a production facility can be complicated, with a constant need to monitor everything from raw materials through to finished goods. To help address the challenges, production managers look to manufacturing execution systems, or MES, to track their production processes. But often these can be expensive to set up, painful to integrate, and under-deliver on addressing their true needs. Autodesk Fusion Operations is different. Fusion Operations is a go-anywhere, use-anywhere, cloud-connected MES and light enterprise resource planning system, which capitalizes on the use of web browsers and mobile devices for operation. This minimizes the IT overhead needed to get you up and running sooner, and gives you the flexibility to start managing your production data today and adapt to your business as it grows. Focus on what's important, like monitoring your operations through production tracking dashboards and audit-ready quality compliance reports fed by real-time information collected from the shop floor, making it easy to visualize your production efficiency all the way from orders to shipping. Manage your teams, machines, and materials to optimize your production capacity and increase manufacturing throughput with material and resource planning, helping to minimize waste and reduce the environmental impact of your business. With scheduling for preventive or corrective machine maintenance to reduce production downtime. And integrate with upstream or downstream resource planning, customer relationships, and product lifecycle management systems to keep your data synchronized and prevent duplication. So, what do you need to improve your production workflow and execution, cope with change and quality management, or get visibility on throughput and machine maintenance? Get your business future ready with Autodesk Fusion Operations.
So, in short, Fusion Operations will, in its simplest definition, it helps you to transform your production floor into a completely digitized process with the aim of driving the operational efficiency thereof. Okay, so why do we use Fusion Operations? Why would we use Fusion Operations? It's a modular and flexible web and mobile application. It's very, very easy to implement. It's very quick to implement. It's merely a question of attaching the devices to the users, and the users need to just be given access to the system. So, gives you real-time inventory and production tracking. So what that does, basically, it's got dashboards that show whoever wants to look, whoever's an admin user, to be the ability to look at and analyze the data in real time in order for us to be able to change our production process on the fly if needed. Data capturing is instant, where we turn our standard tablets and smartphones into instruments of process tracking, all right, into sensors and aggregators. The quality control and traceability of the products. That's something we can actually set up a inline quality control process into a Fusion Operations system that triggers a milestone, so that when you actually do complete production of a particular component, you would then trigger a sequence of events, which then asks you to make sure that the quality of it is up to scratch. And this can be done on a percentage basis if the need arises. So it'll be randomized. And then your MRP, or your materials and resource planning. Again, you can go look at the stock availabilities before you start the process. Resources, we're not even just talking about materials or raw materials. We're talking about the people, the process, and the technology that's available. All right. So, like, let's say, for example, you've got a CNC machine, and if that CNC machine is operating 24 hours a day, 7 days a week, and it's actually being booked up for the next 3 weeks, we need to know that in order for us to be able to, reschedule our planning and actually work out our output time. Okay, so those sort of things are the major reasons why Fusion Operations is for you. Key outcomes coming from a Fusion Operations installation is that we can increase the flexibility of our manufacturing, the agility of our supply chain from a manufacturing perspective, and reduce resource consumption. Now, all of that points towards lowering costs, yes? And those costs is a key driver in today's market, especially considering the international trade fluctuations that have been happening in the recent past. So things that have been changing in terms of trade agreements that have been happening, or the lack of trade agreements, or the tariffs that have been pushed in. All of those sort of things will definitely have a role to play, and wherever we can save costs. And it doesn't even necessarily need to be specifically in reaction to something like a tariff. Saving costs increases production profitability, and any increase in profit is always beneficial to the organization. So from a business perspective, we can better plan our forecasts, better show our forecasts, and then also assist to reduce the environmental impact. So collaboration and data exchange between team members and between management and the factory floor, also very, very important, and something that definitely can be done using Fusion Operations. From an IT perspective, we'll look at it saying that the implementation time is very small. We don't need a lot of time to implement it. It also can be implemented on the fly. So as you're running through production, you can start adding things to the back end. That allows you to sort of mimic your paper traveler method, to mimic your Excel sheet or spreadsheet, to mimic your whiteboard. Nobody's saying you need to get rid of the whiteboard, but we can use the whiteboard as a visual sort of aid more than anything else. But on the same sort of token, everything is on the system, and anybody who has access to the system will have access to be able to see what's happening and to sort of analyze data on the fly. Okay, and that leads us to the data-driven decision making that can happen in real time. Key features, just briefly, is what are your jobs and tasks? We'll talk about how Fusion Operations does assist. So Fusion Operations goes beyond the shop floor and supports all the other needs of the business process. This is from order shipping, sales, purchasing and inventory management, manufacturing resource planning, scheduling, production scheduling, job tracking, quality control, and traceability, as well as maintenance management. Now, what you note is that we will then actually be able to set up Fusion Operations so that you can track your materials, you can track your machines, you can track your users, you can track your production flow as well as your job process. Okay, and that can be done very visually, where we talk about drag and drop scheduler we're speaking about. Then we've got customized quality checklists, and we'll look at a little bit about that in our demonstrations that we'll be following just now. So let's quickly run through a couple of demonstrations as to the workability and the functionality of the tool. Used to be called ProSmart. It is currently called Fusion Operations. This is basically the dashboard that you're looking at as it stands. We're looking at all of the sales orders that have come through from the Fusion Operations tool. And then when you go into a quote or a sales documentation, we go into a quote, we can go and have a look, see at the quote, what's going on, and then see what is needed. So if we quickly check to see what the requirements are, so you can see what the quote costing is, what the quantities are as required are, and such. From there, we can then take it further and edit the sales order as needed. And from this perspective, you can see that the sales team can also then use this tool to carry on with their process. So that then goes and adds the sales order into your system, and then from the MES system you can then use the sales order to create a quote to a sales order, and then from a sales order to a production plan. So the next thing we're going to look at there is from taking it from a sales order to scheduling. So from the sales order, now we can start scheduling the in place. You've got nesting, cutting, pressing, and packing. And then on the blue icons are basically the ones that show the entire job process. So it essentially, if you have a output to attend, you have multiple processes that it needs to follow. So that entire output will then be shown as a broken down process depending on how the tracking is being done. So this is from an operational perspective. Then you look at it from a machine perspective. You can see how the machines are scheduled for each operation and for each product that's being designed or manufactured by the machine. In this case, we can also use interchange that with operators as well. So you can see there where the one machine is sitting at 300% capacity, that is well loaded, and visually you will be able to have a look at from a job perspective, and there's your job tracker. If you see that all of the jobs are now being scheduled per product, and then you'll see that there's an overscheduling on a specific machine, in which then you would do a visual and drag and drop move of that particular, of any specific jobs that you could push out. So if you can go and analyze all of the jobs that you have that need to run through that machine, you could look at which one is a little bit less urgent and take it out of the production schedule or move it a little bit further along the line, so that you will be able to then free up the machine for the next process or the ones that are a little bit more urgent. So in this way, visually, you can then create your schedule, set up your job scheduling, set up your machine scheduling, increase, decrease, or leave machine utilization where it is. Because look, you've put money into the capital equipment, which needs to run for you to make money. So again, back to increasing efficiency. So if the machine's running, it knows something is coming out, and there's money happening. If the machine isn't running, or if there's jobs waiting at the machine to be run, then those jobs are costing you money. So simple little mathematical equation there is that if the job is not going through the process and it's standing, it's costing you money. If it's going through the process, it's making you money. So either which way, we would have to have a look at that, and then from there you can start finding where the production bottlenecks are and mitigate accordingly. Here, what we'll look at is basically a stock check or an insertion of material into stock. What you're going to see is it's goods receiving that's being added in. So just as an aside, the little iPhone image that you see on the bottom right-hand side of your screen is basically the interface that will be used by the users and the specific job applications specialists, who will then update the system, and as it is live, it will update into the system. So just keep in mind, though, that this is a cloud-based system and can just be connected to. So what you'll need to do is download the app, and then you connect into the cloud. This is cloud-based, and it doesn't require any additional server hardware or any of that to be done. And as it stands, something that's very, very easy to connect to and easy to adopt. Okay, so what we just to continue there, you'll see that there's goods receiving that's being happening there, how much quantity is being added into the stock, and where it's going, which warehouse it's going into, and what the lot number is. Okay, and we click confirm, and then it's going pushing into the warehouse and into what bin. All right. That then updates live your system with the amount of stock that you have, so that in the event that there is actually stock required or raw materials required for the manufacturing process, you can then put the orders in accordingly. You can also create an alert in there saying that if your stock level is below a certain value, it creates a message that says, okay, you need to order a little bit more stock to fill up these shelves, because remember, you need to have some form of a production buffer, especially considering the issues that we have, and that also assists you to plan for it and make your process more of a just-in-time type of process. So you have the products, the raw materials needed as the production needs to happen on it. Okay, and then finally, we'll quickly look at this video here. It's connected directly into Fusion. Going straight into the production management tool, which is your ProdSmart or Fusion Operations in this case. Nowadays, you go into the Fusion Operations, then you start inserting your job card number, your user number. And here you can automatically tell it that certain documentation gets uploaded to the system, and the system contains your entire quality policy. It contains all of that data, and then you have to approve it, agree with it before you carry on. Then you start inserting the production, and as the production is being completed and as it's being pushed out and flagged or scheduled as completed, it then takes you directly into a quality control worksheet. Say now, it'll tell you, did you check the model for ironing issues in this case, and all of the other ones that are down there. You can then start looking at and specifying whether it's production passed or failed. And this again informs the real-time data that goes back to the system or back to the management team. So if, for example, you can start telling them, okay, you start seeing that, okay, out of 100 units, 10 of my units are outside of process or something is wrong with it. Immediately before your entire batch lot is completed, we can go and have a look while the process is running, or we can actually use the Kanban system and the add-on cord and stop the whole process before we actually end up manufacturing 10 or 20% defective products. And that's also something that you can stop the process, fix it, and then again reduce the wastes, reduce time waste, reduce raw material waste, and also reduce the amount of rework that you have to do. So again, you're running a CNC machine that takes 5 hours to actually finish machining a component. I mean, this is a small component I'm talking about. And then it comes out wrong because your spindle is half a degree outside of vertical. Okay, so inline, if you see that production is coming out, you can stop the thing and then carry on without having to go and check all of the components at the end of the production run and see that a certain portion of them are defective. Okay, so that's just a quick little demonstration of what Fusion Operations can do and what it does and how it helps. Let's quickly run through do a quick summary as to what we have discussed so far. So in our standard production process, we've got a paper traveler with the production or work order that goes through, check for materials, go through each of the operations. Then the work order gets returned and recorded, and the data gets entered and then analyzed for the next run or for future run. But in the case that there's something that happens where your paper traveler comes back, you're filling in all of your details and all of your products are complete and with no defects and so on. You've got a situation where, okay, you'll just probably take these pieces of paper, fill it up and file it, move it on. Without realizing that there's operational inefficiencies, operational inaccuracies. And again, whether it's within tolerance or not, that's another question. But all of that, if you had the inline data, you would see that, okay, no, my machine is standing for an hour before it actually needs to start working. Why? Because it's running another process before this one. And this increases or improves the flow of the process. Now, what Fusion Operation does is it empowers the manufacturers to allow them to replace the manual labor-intensive work for data entry and data processing to make it quick, easy, efficient, and immediate as a digitized process. By doing this, there's a much larger flexibility, the ability to make changes as and when needed on the fly, and the ability to make decisions as and when it needs to take place. Because if you have a problem with in the beginning of your production run and you don't realize it's there, you only find out at the end of your production run. That's not something that we want to deal with. That improves, that again, scrap, rework, waste material, waste cost, waste time, and waste electricity as well. Okay, moving on. All right, so what are we benefiting from using the software? Digitization and automation, sure, yeah, absolutely. Real-time visibility, we've spoken about it a lot. And ultimately, this drives us to a reduction in cost. And what does that mean? More money. I mean, more profit. Or in the other alternative sense is you can actually reduce your costs so that you can sell more into the market. So depending on the market itself, if your production costs come down, you can potentially keep the same margin and lower your output costs. And when your output costs are lower, then more people will buy it. Then you get more and more volume. So that's a different way of looking at it, but on the same, it kind of in the same vein, you can make more money when everything costs you less. And those are immediate results you can get. Immediate as in you implement the system, you can see all of these immediate data that you can use. The data comes to you, you can analyze it immediately, work on it, and then those are your immediate term results, and also the adoption speed as well will assist with that. And in terms of longer term, as your data gets added to your system, more and more data gets added to your system, you can start picking up trends and bucking trends and realizing, okay, this process has certain quirks and things. And also another interesting thing is that if let's say you're tracking your machine. So if the machine is now taking a little bit, let's say 5 minutes longer per component, and that starts to become a trend, then you can start also finding maintenance issues that could be causing it. So say, for example, you're changing of your tooltips as an example. If your bandsaw is working slower than usual, it could mean that your saw itself is losing its teeth and would need to be replaced. And then you can start tracking at what intervals these changes need to take place so that it actually creates a minimum of downtime for you as a manufacturing organization. Then finally, let's see, what can we do to help you? So if any of this that we've spoken about is resonating with you and you think there's anything might help you, so please give us a call, contact us. I will put up the contact details for Baker Baynes at the end. And we will provide you with consulting and training, as well as if needed, we can also assist you with the software. So that's something that we can actually do going forward. And if you do feel like Fusion Operations is something that can be helpful, please give us a shout and we can have a conversation about it. Thank you everyone for attending the webinar. Sincerely appreciate your time and effort spent to do this, to attend. And yeah, until the next one, we'll catch up then. Have a lovely day, everyone. Thank you very much.